Scene 3. After meticulously reviewing all the checkpoint data, the team turned their attention to CCTV footage along the highway to Hyderabad. They began gathering surveillance recordings from every possible location: restaurants, hotels, petrol pumps, and other establishments lining the route. Over the course of 2 to 3 days, they compiled a substantial amount of footage. Their efforts soon paid off. Two pieces of footage stood out, both from Anantapur, a town located nearly 100 kilometers beyond the KIAP checkpost. One camera was positioned 110 kilometers past the checkpost, the other at the 113-kilometer mark. Recognizing the potential significance, they extracted the footage from both locations, broke it down into frames, and organized them meticulously into separate folders for detailed examination. These folders held the extracted frames from the CCTV footage. The next step was clear. Each frame needed to be examined to identify and extract the registration numbers of every vehicle captured. To accomplish this, the team employed EasyOCR, an open-source optical character recognition library. With its capabilities, they could convert the visual data from each image into readable text, making it possible to detect and record vehicle registration numbers with precision. The first step was to establish a clear mapping between each footage ID and its corresponding folder location. This organization would streamline the process of accessing and analyzing the frames. Once the mapping was in place, the team developed a function designed to take two parameters: the footage ID and the vehicle registration number of the missing friend's car. Using this function, they systematically navigated through each frame within the specified folder. Each frame was converted into text using EasyOCR, enabling them to scan for any visible vehicle registration numbers. Whenever a registration number was detected, it was compared against the missing friend's vehicle details. If a match was found, the system would immediately print out the registration number along with the timestamp from the frame in which it appeared. Next, the team moved on to the implementation phase. They began by writing the code to accept two key inputs: the vehicle registration number and the footage ID. With the framework in place, it was time to begin the actual execution. The program first prompted for the footage ID and the vehicle number to be searched. They entered the ID corresponding to the 110-kilometer point and provided the registration number of the missing friend's vehicle. The system processed the frames one by one, scanning for the target number. Success! The vehicle was found, along with the exact timestamp captured in the footage. This confirmed that the car had indeed passed the 110-kilometer checkpoint. With that confirmed, they moved on to the next location, the footage from the 113-kilometer point, preparing to repeat the same process in search of further clues. At the 113-kilometer checkpoint, the results were different. The vehicle number they were searching for was nowhere to be found in the footage. Frame after frame was analyzed, but the car never appeared. This led the team to a crucial realization. The missing friend must have taken a deviation from the highway somewhere between the 110-kilometer and 113-kilometer points. Within that narrow 3-kilometer stretch, something had changed. Either he had turned off the main road, or something had happened to him in that area. What exactly occurred in that brief but critical span remains a mystery for now. What happened to him? We'll uncover that in the next scene. Thank you for watching.